Hello, this is our team project submission for course GDP 1 in Fanshawe College, and the team members are myself, Upendra Nagarajan, and my friend Mohammed Ibrahim. And this is technically a technical demo where we implemented all our stuff, which is from graphics, physics, and frameworks, the subjects that we've learned in our course till date. And it's just a demo where it's not a game. We haven't made it as a gamified way, but it's just a demo. So let's jump into it. Alright, so we have implemented almost every topics that we have learned so far. We have a model loading, and quantum code physics, and we have implemented techniques like sweating and most importantly, we implemented the sound system, which we are using as one for body technique where it's just a cloth simulation and it runs on a separate thread, and we use the threading system to update the software physics. Almost covered every topic, and my friend will explain which topics which is based on the mesh instance and all of this.
Those trees are in mesh instancing, so it's just one model with 100 different transforms. So that's how mesh instance works. And if you see this giant big tree, it's under 3 LODs. So how far the main camera is, the LOD directly visible. You see closer to it, larger polygon that's how it is. And this is a simple setup that I have used it. So you see there's a small animation things happens. It's because if I'm just player, I have implemented this third-person player controller, where it's just a capsule collider, and this there's a camera being following up, and for the vector system, I have used camera collision. So if the camera collides with any other colliders of the object, it just clamps near to the player, like you can see here. Again, the post-processing stops. So for the controls, it's just WASD for the movement, and if you hold shift, they will run. And for the camera movements, it's X and Y axis of the mouse inputs, and it works for the joysticks as well. So if your joystick is being connected, it's the left analog triggers for the movement, and the left thumb button for the sprint. Moreover, for there is a button called A for the animation. Yeah, here I've used post-processing Q volume, so it's just a box trigger kind of thing. When the camera enters the region, so it just changed the post-processing of the current camera. This was inspired from the Unity, where they have like volume post-processing boxes. The core, what I implemented, the technical aspects. So far the player, I have used state machine for the player. So there are like 3 states as of now: idle state, run state, and the magic state. The states can be visible over here. So I have 3 states. So within the states, each animation's been clipped, and moreover there are some translation and inputs been happening in the run state and idle state. Yeah, and for the camera, it's the pretty much same. Just I am taking the axis of the mouse, vertical and horizontal axis, and for the joystick, I am taking the same as the left axis and right axis. Yeah. Here I have used the raycast system, as I said you before, like when a camera has been hit to any other colliders around the world, it just pans to the clamp distance, like for 1.5 distance from the player, so it just goes near based on this distance. Yeah, this is how my camera controls being navigated as of now. And for the physics X, I have implemented this box collider, capsule collider, and mesh collider, and sphere collider. So in the technical demo, we have used box colliders and capsule colliders and mesh colliders. So the terrains around there, and some trees has the mesh colliders, and other stuff, interactable stuffs, has only the box collider. Yeah. and for the occlusion, as you know, as you see, you might have not seen this in the scene view. Let me show you in the scene view. I mean, yeah. If you see, your play camera has been like changing around the world, but the models has been not displayed. It's because of the occlusions. So in this state, that we have satisfied the game gems and algorithms technique. For the other technique, we have used for the LOD. That's a part in occlusion. So this occlusion has been made from physics 6 as well. So they have a BVH skull option in physics 6. So I have used and wrote a wrapper class around it to take this out in our game engine. Yeah, and for the LOD part, so in our model class we have a property called add LOD. Add LOD group. So if your mesh have like 3 LODs inside it, you can just mention which indices needs which distance to cover up. So I have one main camera, so based on that the camera will cull the distance. The occlusion will be happening based on the camera's distance and the model's position. So it will be like changing the elements based on it. So that's how the LOD works here, and other technical stuff. And other technical stuff, we have implemented joystick input as well, so we can able to control via joysticks as well. And for the mesh instance, I have written a shader called grass instant shader, so where that okay, here comes the shader. So this instance model ID will be coming from the model, instanced as an instanced model from the loading one mesh in the area. So within that I can able to like load nearly 100. I guess I kept the limited to be 100. 100 models out of this grasses as of now, and these are the values that helps for me to just move the vertices of the grasses, like as in the wind. This is for the grass mesh instance, and animation. This is not. Okay, and this physics skin mesh render is responsible for the characters animation. So here I can able to load multiple animations and name it as what animation that we want, and even if I want to play the animation, it will loop every frame if I set the animation loop to be true or false. So if you want to blend animation between one another, you can play using like play blend animation. This just requires the animation and the time that needs to be blending. It's basically a looping between two animations from your current and previous. So this is for the animation techniques. So far we have covered most of the things, and it's all I have to show. Thank you for watching our demo, and I'll just pass.
Alright, so that's basically it, and I forgot to mention about the particle system, and as you can see, we took reference from mostly Unity, which has the properties called color over lifetime, size over lifetime, etc., and that's where our main idea came from. I'm just gonna show you the inspector of our particle system. So let's say this is a fire particle system, and you can see the references from Unity. We have our emission, we have velocity over lifetime, size over lifetime, and our shape. You can pretty much select shapes from our options. That it has 3 shapes as of now. So the code is basically, this is it. This basically renders our particle up depending upon the what emitter property we are choosing and what kind of property, like let's say color over lifetime or rotation, etc. That's how the particle system works, and the major update happens in render particles. This is where the major update happens depending upon what type of property you're choosing. And you should have seen the in our technical demo there is a fog system, which is basically I'm changing the color of the fragments based on the camera's position. See, there is a grayish foggish kind of thing, and the fragments color changes depending upon the position of your camera. This technique allows us to smoothly blend between the fragments. That gives you an look where it blends into a fog or something like that. You can control all the fog properties here. You can change the density, you can start, and you can change the colors, etc. And the main fog properties happening inside our shader, which is our fragment shader, which technically I should have done it in the vertex shader, but the inside the fragment shader I'm getting all the values where as you can see I'm using 2 different fogs, but for just now I'm using exponential fog. But this is how I calculate the position of the fragments and the camera's position, and mixing it depending upon the location. That's how it happens. And the other thing is that we are using soft body, and the soft body physics is our own physics. We are calculating the physics inside the soft body physics inside the thread update. Mostly our thread handles the physics update of our soft body, and this is how our soft body is initialized. First we initialize the vertices of the mesh, and we update the mesh according to the Verlet integration, which we implemented in here. So our points and constraints get calculated, and that's how the soft body works. And in our threading system, this is where the whole thread happens. We are just updating the wallet integration of our soft body mechanics inside the soft body thread. And to notable, the thing is that we are using a windows.h thread system, and we are not using the C++ thread. And I have a template programming class where I use the critical section and interlocking between the variables that I need to be interlocked or need to add it into a critical section. And yeah, that's pretty much it. And I think we've almost covered all the topics from our course. And this is not constrained to where we can make only a technical demo. We are aiming to make a game out of our own engine, which is possible at some point in the near future. But yeah, let's hope so. Thank you for watching.